Hello, welcome back to our first principle review. So this is the second problem that we're going to solve using the first principle. Alright, before we begin, don't forget to like and subscribe. Okay, let's get to it. So it is said that we need to find f prime of x, of which we have f of x, isn't it? F of x is given to be this, not really the prime part that was given. So say we've been given a function as f of x being equal to 1 over x plus 1, and we need to find the derivative. So using the first principle, we'll say f prime of x is equal to lim as h approaches 0 of f of x plus h minus f of x. And this will be over what? H. After that, we have to collect data. So we need to look for f of x, of which f of x is 1 over x plus 1. And f of x plus h will simply be 1 over, wherever there's x, we put x plus h, then plus 1, which will in turn be 1 over x plus h plus 1. After that, all we have to do is to plug back in the first principle equation. This implies that f prime of x is equal to lim as h approaches 0 of f of x plus h, which is 1 over x plus h plus 1 minus f of x, which is 1 over x plus 1 over h. Now, every time the numerator is not a single fraction, it is mostly advised to make it a single fraction. So let's do that. So we say data, we have 1 over x plus h plus 1 minus 1 over x plus 1. We look for the common denominator, which will be the same things that we have as our denominators, which will be x plus h plus 1 and x plus 1. So basically we say 1 has to multiply that entity. So it's going to be 1 times x plus 1. Then you maintain the sign. So it's going to be minus 1. Most people say you cross multiply, but that's almost like the same knowledge behind it, because every time we're trying to express two or more fractions as a single fraction, that's the idea that we always think about. So this is going to be x plus h plus 1. If we simplify furthermore, this will be x plus 1, because 1 won't change anything. Then the minus 1 multiplies everything inside here. So we're going to have minus x minus h minus 1. And it's over x plus h plus 1, then x plus 1. So the x cancels out with the x, the 1 cancels out with the 1, and we end up having minus h over x plus h plus 1 and x plus 1. So now that we have it like that, we can put it back. So this implies that f prime of x is equal to lim as h approaches 0 of the numerator, which is now minus h over x plus h plus 1 and x plus 1. And this is over what we have initially as h. Then f prime of x is equal to lim as h approaches 0 of minus h over x plus h plus 1, then x plus 1. Then since it's division, I'll just say divided by h over 1. Once we do that, we're just going to change division to multiplication, and you have f prime of x being equal to lim as h approaches 0 of minus h over x plus h plus 1, then x plus 1, then times 1 over h. So h there, 1. H there, you remain with 1. So you have f prime of x being equal to lim as h approaches 0 of, now we're going to just have minus 1 over x plus h plus 1, then x plus 1. Now at this point, you can plug in for h, and we say f prime of x. Remember, if you start plugging in, this guy disappears. So we have minus 1 over, so x plus 0 plus 1, then x plus 1. And this is equal to negative 1 over, so we're going to have x plus 1, then x plus 1 again. Therefore, we say f prime of x is equal to negative 1 over, x plus 1 times x plus 1. This is you repeating the same base. So this will be x plus 1 to the power 2. That is the final answer. Alright, thanks for watching. See you in the next problem.